Okay, so we're going to take a polynomial and we're going to divide it all the way down to its binomial factors. So let's start with something like this. Let's say we have y equals x to the fourth minus x cubed minus 28x squared minus 20x plus 48. If I tell you to find binomial factors, what I'm looking for are the factors that are like this, x plus 5 or x plus 2. These are binomial because they have two terms, and we know that when we have like 4 of these, it's going to give us, if we multiply them together, it'll give us a polynomial. Now, I just made these numbers up, so those aren't them. But that's the format we're looking for. So that's what we're after. So to do this, sometimes you're given a factor to start with that you can use to divide by. Sometimes you're not. When you are not given something to start with, you have to figure out where you can start. And the way we're going to do that is by looking at our constant. So here our constant is 48. That means that the potential factors we're going to use and the potential intercepts we're going to find are going to be factors of 48. So what are the factors of 48? Let's see, there's 1, 2, 3, 4, not 5, how about 6? Yep. 7, nope. 8, yes. 9, no. 10, no. 11, no. 12, yes. Do you see where I'm going with this? Okay, what else do we have? Let's see. 2 times 12 is 48. 3 times 16. 4 times 12. 6 times 8. Oh, and then 2 is 24. Okay, now, the only other piece to this is that we could have the positive or negative of all of these, right? So each one of these is potentially either positive 2 or negative 2. Positive 3 or negative 3. Positive 4 or negative 4. Positive or negative for all of them. And this is how we show that. We just write these little plus and minuses. So these are our potential factors. All right, these are our potential factors. Now, we can just start dividing by 1 and hope for the best and hope we get a remainder of 0. Or we can do what we call the remainder theorem, and we can do some trials. So if we do the remainder theorem trials, what we're going to do is we're going to plug each of these numbers into x and hope that we very quickly get 0. Because the faster we get 0, the better shape we're in. So what should we start with? 1. Let's start with 1. Seems like a good place. So I'm going to plug in 1 for x. So I'm going to say y equals 1 to the 4th minus 1 cubed minus 28 times 1 squared minus 20 times 1 plus 48. I cannot recommend enough that you do not do this by hand. You should take a look at these and do rough estimates and see if it's even like worth putting in your calculator. Sometimes it's clearly going to be like 100. So if you can do a quick mental estimate, save yourself the trouble. If you think it's close, put it in your calculator. Be very careful to put brackets around. When you get these negatives going and you're cubing things, it can get tricky. So let's not make silly errors here. Okay, so if I put all of this in my calculator, I'm going to get 1, let's see, minus 1, minus 28, minus 20, so minus 48 plus 48. Okay, so this is going to give me 0. Okay, ding, 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 we have a winner. So we found 0, which means that positive 1 is a factor. However, if positive 1 is our x-intercept, then what binomial would have given me positive 1? Well, the binomial would have been x minus 1. Think in terms of intercepts. If this is what you had, don't you know that the x-intercept is positive 1? So we're working backwards. So therefore, our binomial is x minus 1. So now that I know that, I'm going to be able to take that and divide by it. And if I go divide my big polynomial by it, then it's going to give me another polynomial that I can divide by as well. So that's what I'm going to do. I'm going to slide this over here, and I'm going to very quickly divide by this. Oops. Well, only if I can find the right pen. So I'm going to divide by x minus 1, and I'm going to take my x to the 4th minus x cubed minus 28x squared minus 20x plus 48. And I'm going to do all that division. Okay, so now that I'm done with that, here's my new polynomial that I found. And remember, I know I've already got one of my binomials. So I need to divide again. So I'm going to repeat my process of doing remainder theorem trials and ask myself again, what are factors of 48? Now, unfortunately, we still have 48 as a constant. But sometimes after you divide, your new constant is like 6. And it's really limited numbers to look for. So, okay, so this time, let's see, we already tried positive 1, let's try negative 1. So if I plug in negative 1, I'm going to have negative 1 cubed minus 28 times negative 1 minus 48. And let's see, I get negative 1 plus 28, nope, doesn't work. So negative 1 doesn't work. So let's try another one. Let's try negative 2. So negative 2 cubed minus 28 times negative 2 minus 48. Let's see, put that in your calculator. Be really careful that that negative 2 goes in the bracket. You don't want to goof that up. And then you're going to say that, oh, I think we get 0, don't we? That equals 0. So if negative 2 is my x-intercept, then what is the binomial? X plus 2. Okay, so now I have found a second binomial. Now you can divide by this. So I'm going to keep making this thing tiny. If we divide by that now, we're going to take our new binomial. Oops, why do I do that every time? Take our new binomial, which was x cubed minus 0, don't forget your placeholder, x squared minus 28x minus 48, and you're going to divide by x plus 2. Now this time, once you do all that division, you should get down to a quadratic. And if I'm not mistaken, the quadratic you're going to get down to is going to be x squared minus 2x minus 24, I believe. Once you get to this quadratic, you can just factor that normally, and when you factor that, you're going to find what multiplies to negative 24 and subtracts to negative 2. I'm going to say x plus 4 times x minus 6. So now at this point, you've got 4 binomials, which is great because you were dealing with a quartic function. So we're looking for 4 binomials. So we have x minus 1, x plus 2, x plus 4, and x minus 6. Now as your final step in this, you can take those and determine your x-intercepts. So we know that we've got x-intercepts at 1, negative 2, negative 4, and 6. And we know that we have a y-intercept at 48. Because that was our constant. So now this can all be graphed. You can take your graph and we're going to draw what's called a rough graph. And all we're going to do is label our 48 on our y-intercept. We're going to label all of our x-intercepts and plot our points. So we've got an x-intercept at 1, at negative 2, at negative, nope, I can't count, negative 4, and positive 6. 2, 3, 4, 5, 6. This is quartic. And it's positive. So we know that it's going to go something like this. Woo! Okay? So it should look something like that. Now, we don't know how high or how low these valleys go, but in a rough graph, we know a couple things. We know direction, up or down. We know shape, this kind of W shape, and we know our intercepts. And that's enough to draw a rough graph that we're after. Okay? So as a quick recap, when you don't have something to multiply by or to divide by at the beginning, you look at your constant and you come up with all the factors. You then try those factors using the remainder theorem by plugging them into your function. When you get 0, you know that you have found an intercept. Turn that intercept into a binomial factor and then divide. Okay, you're done.